My name is Sam, and today we're going to talk a bit about the underlying mechanics of the theory of plate tectonics. So, plate tectonics describes the motion of the Earth's surface, and you often hear about it in terms of causing earthquakes and volcanoes and tsunamis, but we're going to take a step back and actually try to understand why plate tectonics happens in the first place. And to do that, we need to start with knowing the structure of the Earth and how that all fits together. So on the right-hand side of my screen, I have a cartoon drawing of a cross-section of the Earth, and it has four main sections. We've got the thin outer section, which is called the crust. We have the thicker section, the mantle, that's the orange section there. After the mantle, we start getting more dense and hotter, and we have what's called the outer core, because, well, it's part of the core and it's on the outside. And then we have the inner core on the very inside of the Earth. So, the crust is more of a colloquial term. It's a common term, but it's not a term that scientists use for that structure of the Earth. Scientists use the term lithosphere to describe mostly the crust. The lithosphere also involves the very top of the mantle. So the lithosphere it comes from the word, it has two parts. It comes from the word litho, which means rock, and sphere, which, well, is a sphere. So this is describing the solid part of the Earth. So, in all actuality, the outside of the Earth is technically called the lithosphere. So when we talk about the lithosphere, that's the section where we live, right? The lithosphere is made out of solid rock for the most part, right? So it's solid, but it is made out of those chunks, and we'll get there in a little bit. We have the mantle. The mantle is not so much liquid. People think about it as a liquid a lot, and that can serve its purpose. However, the more accurate way to describe the mantle is scientists use the word plastic, and that's not referring to, your milk jug or your water bottle. They're talking more of kind of a silly putty texture. So it's stretchy and goopy. It's not really a liquid. You can't pour it very well, but it is halfway between a liquid and a solid. It's plastic, it's stretchy. It doesn't go very fast, which is fine, and that's actually probably a good thing, all things considered. But the mantle is plastic. It flows like a liquid does, just very, very slowly. We then get to the outer core. The outer core is liquid metal, specifically nickel and iron. And it's those two metals. They're very common metals in the Earth, and they're very dense. So as the Earth was forming, they ended up congealing in the center. And then we have the inner core. The inner core, again, is nickel and iron, but this time it's solid. It's not solid because it's cold. It's solid because it's under so much pressure that even though it is very hot, the inner core is under so much pressure that it is forced to stay a solid. As we go into the Earth, you go from cool at the top to hot in the middle. When you have a difference in temperature, it's what's called a gradient or a differential. When you have a difference in temperature like this, you end up with what's called convection. So if you've ever boiled a pot of water. In a pot of water, the bottom above the stove is going to be hotter than the surface. So what happens is the water at the bottom gets heated, rises up, and then it cools off at the top. And the same type of thing happens with the mantle. So it moves up from the bottom and it falls down from the top because the top is cooler and more dense and the bottom is hotter and less dense. So less dense stuff rises. this doesn't always do it in the most coordinated way. So you end up with some sections that go up and down like this, but the section next to it might also be going up and then down like that. So when you have these different parts convecting differently in different directions, maybe they're both going down here, you end up with different cells moving in different directions. And if you have a solid on top, like our crust, we said the lithosphere is solid. The solid on top of the liquid, and I said that the lithosphere involves the top of the mantle, and that's where this comes into play. The top of the mantle is stuck to the bottom of the crust. So you end up with a layer that is solid that's attached to the top of a convecting pseudo-liquid. So it's moving up and down, but the crust can't move as easily as the mantle can. So what happens where you get these different cells meeting, the edge cells are going down at the same time, like on the right-hand side, you end up with what's called a convergent boundary. When you have ones that are going up at the same time, like the one on the left, you end up with a divergent boundary. So when both sides are being pulled down, they're being pulled together. And when you have both sides coming up, they're being pulled apart. And this, in essence, is why we have plates in the first place, because when you have a solid stuck to the top of these cells and moving along the top of the convecting mantle, that you can't get a solid sphere. You end up having to break into pieces, which we call the plates. We're going to talk a little bit more about the plates and what they actually do in a later video. But just for now, we just want to start with how the Earth works to make the plate tectonics in the first place. So we'll leave it there for today.